Welcome to clickmyproject.com.
Our product title is Multicell Switched-Inductor Switched-Capacitor Combined Active Network Converters. Next we see about abstract of our product. In this proposed implementation is based on renewable energy resources such as solar panel is used to input source. After that fed into active network converter and switched inductor. Switched capacitor block. Here the voltage will be boosted in order to avoid the influence of leakage inductor in coupled inductor based converter. Switched inductor, switched capacitor and active network converters have been developed. The proposed converters combine the advantages of SL bar SC unit and active network converter. Compared with the previous high step up inverters, the novel converter provides a higher voltage conversion ratio with a lower voltage current stress on the power devices. High step up voltage gain DC to DC converters are widely used in renewable energy power generation, uninterruptible power system, etc. In order to avoid the influence of leakage inductor is coupled inductor based converters. Switched inductor boost converter, switched capacitor boost converter and active network converter have been developed with the transition in series and parallel connection of the inductors and capacitor. High step up voltage conversion ratio can be achieved. This proposed design, the characteristics of the switched inductor and switched capacitor cells make some comparison between the ANC and boost converter. Based on the analysis this proposed system, the multi-cell switched inductor switched capacitor combined active network converters that combine the advantages of SL bar SC unit and active network converter. Compared with the previous high step up inverter, the novel converter have high efficiency and high switching efficiency. Next we see about the flow diagram of our product. This is our flow diagram. In this flow diagram the input source is a solar panel. Here the solar panel is connected to the DC to DC converter with active network cell and switched inductor and switched capacitor cells. Here the solar panel consists 72 solar cells. Those 72 solar cells are connected in series and that solar panel is supplied from the solar irradiance. Here we give 1000 range, that unit is watts per meter square. So given watts per meter square 1000, then connection of 72 cells, the output of the solar panel is 44 volt. Then that voltage will be connected to active network converter and switched inductor cell and capacitor cell. Here the capacitor and inductor cells boosted up to some level, and also using of active network converter the voltage will be boosted again twice in the output of switched capacitor and switched inductor. So the overall conversion efficiency will be increased using of this converter types. So we using switched inductor and switched capacitor separately, having large amount of sizes. So using of this kind of topology the overall system size will be reduced. Finally the output will be connected to the load. Here the load is a resistive load or maybe a inductor or capacitive loads. Next we see about running process of our product. In this proposed implementation is done in MATLAB simulating environment. First open the MATLAB window and next create a new model file. After creating the new model file, we are assigning the elements as per the circuit diagram. We are arranging the circuit diagram as per the paper. After that we connecting the circuits and given the parameters for our requirements. After circuit connection we click the run icon. After clicking that the output waveforms are shown in the corresponding connected scopes. First one, the IV curve, that is plotted between the solar current and solar voltage, that is connected in the solar panel. So this is the IV curve. The y-axis is current, x-axis is voltage. So next one is the PV curve. PV curve is plotted between power and voltage in the solar panel. The y-axis is power and x-axis is voltage. And the next one is the separate waveform, that is plotted between voltage, current and power. The x-axis is a time. So this is the waveform. First one is the power, and x-axis is always time in seconds. So second one is current, and third one is the voltage. And next we see about the pulses waveform is generating in the PWM generator using of the MPPT technique and also controller process. And this is the pulse waveform. This is generated in the each divisions from the duty ratio of MPPT. And next one is the output current waveform. Initially they giving them rise time. Due to rise time, the voltage after that the voltage or current will be constant. Here the output current range is 5 ohms, and this is the output voltage waveform. Here the voltage is reached of 500 around 550 at the time of 0.1. So 0 to 0.1 is the rise time. So overall rise time is less compared with the other process. Mainly the conventional method, the conversion voltage level is very low, so overall efficiency will be increased. Thank you for watching this video.